Hello students, welcome back to the lecture series on retrosynthesis. Myself Dr. Rahul Bondwe. I am assistant professor in Department of Chemistry, TC College Baramati. Friends, we are learning retrosynthesis. That means we are going from product to starting material. So in last my video lectures, we already covered simple olefins, alpha beta unsaturated ketones, tertiary alcohols, and simple FGI of functional groups. Okay, so friends, today we are going to learn a very important topic from the retrosynthesis, that is a umpolung of reactivity. Right, you heard it right. It is a umpolung of reactivity. Okay, or umpolung reactivity. So umpolung reactivity is simply a polarity inversion or polarity reversal in organic chemistry. So let's see in detail what is meant by Umpolung reactivity. It is a chemical modification of a functional group with the aim of the reversal of polarity of that group. Okay, so in chemistry or retrosynthesis we already seen donor group and receiver group. Okay, so whenever we see positive charge, we see that molecule as a receiver or electron deficient, but in this case we are going to change the or reverse the polarity of those groups. Okay, so simply umpolong is nothing but a reversed polarity or reversed reactivity. So this concept was introduced by Dr. Seebach, D. Seebach, a German chemist, and Umpolung is German word for reversal reactivity or reversal polarity. Along with D. Seebach, Professor E. J. Corey also worked on the Umpolung of reactivity. Okay, so these scientists invented this kind of concept in organic chemistry. So let's see one example and it will be clear to you what is actually mean by Umpolung. So in carbonyl compound, we already saw the 1,3, 1,4 and 1,5 dicarbonyl compound. For the 1,2 dicarbonyl compound, you can see that if we disconnect this 1,2 di compound in between, so what we will get, we get positive charge over here and negative charge over here. Okay, so friends, previously we saw that this is a positively charged intermediate, so it can be, or this synthone can be achieved by this synthetic equivalent, that is a acetyl chloride, or we can say any living group we can attach over here. But friends, as you can see that this disconnection looks illogical as there is a negative charge over carbonyl carbon. So how we can achieve this negative charge on carbonyl carbon? That answered by the Umpolung reactivity. Okay, so this actually positive charge is on carbonyl group, it can be justified, but this can be achieved by the Umpolung or reversal of reactivity. So this kind of synthone we can get from the Umpolung of reactivity. So let's see how we can get this kind of synthones, or how can we get the this kind of molecule. Okay, this is called as a benzyl. So let's see how we can get the benzyl. So friends, this benzyl can be achieved by reacting two benzaldehyde molecule, but this is not so simple because both the molecule have electron deficient carbonyl carbon. So to get the synthone which having negative charge, what we will do, we will react this benzaldehyde molecule with dithione. Okay, this is a dithione molecule, and you can see that just like a acetyl formation using diol or glycol, we are using dithione molecule. So it will form a thioacetal. Okay, it will form thioacetal. This, due to two sulfur group, this hydrogen now become acidic, and with the help of strong base we can abstract this proton and we will get this kind of carbanion. So actually this is a aldehydic hydrogen which is abstracted by this proton, but due to this two sulfur group, this negative charge is or carbanion is very well stabilized. Now this carbanion will attack on the acid chloride. Okay, this carbanion attack on the acid chloride, and which will ultimately form this molecule. So once this molecule is formed, this diethion protection can be removed by the HgCl2 or any mercury salt. So by treatment of Hg chloride with this diethion or thioacetal or cyclic thioacetal, we will hydrolyze this cyclic thioacetal with the help of HgCl2 and we will get again the carbonyl group. So this is how we are going to prepare 1,2-dicarbyl compound or simply benzene molecule. Okay, so detailed mechanism of formation of this thioacetal and deprotection is in the next slide. So let's see the first formation of this diethyl mechanism, and later on we will see the hydrolysis of this cyclic thioacetal. Okay, now the mechanism of thioacetal formation is very simple. It's simply like a formation of acetal using ethylene glycol. So friends, we have this type of diethyl molecule. The first sulfur will attack on this carbonyl carbon and we get this negative charge over here, which will abstract proton from water molecule and neutralize the negative charge over here. And also the sulfur will be neutralized by the water molecule. So in the next procedure, what will happen? This OH will again protonated and it will leave as a water molecule due to the delocalization of sulfur lone pair. So we will get this sulfonium ion, which is again attacked by this another sulfur atom over here. Okay, so we get the cyclic ring over here, as there are two carbon over here, so we get 5-membered thioacetal, and this is a protected form of ketone. Okay, now this will be treated with the base to abstract the proton from here. So this is a simple mechanism for the thioacetal formation. Now let's see how it is deprotected. So it is deprotected in presence of HgCl2. Sulfur have strong affinity for the mercury, so it will attack on the mercury. One chlorine will leave as a leaving group, and then the lone pair on the another sulfur group will delocalize over here, and the carbon sulfur bond will break. So this sulfonium ion again attacked by the water molecule and we get the OH over here. Once the sulfur is neutralized, then it will attack on the Hg atom and we get again this type of molecule. The delocalization or removal of hydrogen from this OH, or I will say oxidation, will lead us for the this side product and formation of carbonyl group. So this is how we are going to deprotect the thioacetal. Okay, this is how we can hydrolyze this thioacetal to get back the carbonyl group. So this is simple way for the reversal of reactivity of this carbonyl group. So this is widely used in organic chemistry, and there are various scopes to the Umpolung of reactivity. Friends, this is one more slide of deprotection. Not only HgCl2 but oxidizing agent can be helpful for the deprotection of this thioacetal. Okay, so it will oxidize these sulfur atoms and ultimately we will get the keto group as a free product. Okay, so this is another way for the deprotection. Let's see the scope of the Umpolung. So friends, not only the 1,2-diketone, but once we get this kind of masked acylian ion, okay, so this is a carbanion and we can use this carbanion to attack on any electrophile like alkyl halides, okay, and so on. So we can attach any electrophile to this hydrogen or this carbonyl carbon instead of this hydrogen. So once we remove this hydrogen, we can attach any kind of electrophile over here. So this Umpolung of reactivity have wide application in organic chemistry. So we get any electrophile over here, which is not possible by simple normal reactivity. Okay, you can see here this is normal reactivity, which is shown over here. The carbonyl carbon is electron deficient and act as a electrophile. So attaching any electrophile over here is very difficult task. Only nucleophile can attack over here. So by using this diethyl, we can achieve this kind of reactivity. So this is a scope for Umpolung of reactivity. Now let's see another example. So you know that this is a benzoin, and benzoin condensation includes the Umpolung of reactivity. So let's see the retrosynthesis of this benzoin molecule. So as you know that we will move the arrows from this secondary alcohol over here, and we will get negative charge over here and a benzaldehyde molecule over here. So this molecule can be achieved by Umpolung of reactivity. Instead of, as we previously seen that, instead of reacting the benzoyl chloride, we can react the benzaldehyde to get this molecule. Okay, so let's see how other ways, how many other ways are there to get this kind of reactivity. So friends, this benzoic condensation, you know that this is achieved by treatment of 2 moles of benzaldehyde in presence of cyanide ion. Okay, cyanide ion is helpful for the formation of benzoin. So this is called as benzoin condensation. So let's see the mechanism and where the Umpolung of reactivity comes in picture, we will see. So this is a mechanism I found on the internet. So this is a cyanide Cn minus ion which will attack on the carbonyl carbon of the benzaldehyde. This is a normal reactivity. Okay, this is normal reactivity. This is nucleophile, will definitely attack on the electron deficient carbon, and what we will get, we will get this type of cyanohydrin. Okay, this type of cyanohydrin we will get by attack of this Cn minus or benzaldehyde. So once we get this type of cyanohydrin, due to Cn, this hydrogen becomes deficient, or I will say this become acidic hydrogen, and this can be easily abstracted by base. Otherwise it wouldn't be possible to abstract the adiabatic hydrogen from this molecule. So it is uh, possible due to this Cn minus. This become electron deficient or acidic, and it can be abstracted by the base. Once this proton is abstracted, we get the carbanion, and which is again stabilized by the Cn minus or electron withdrawing group, which will attack on the another molecule of benzaldehyde. So we get this kind of intermediate after the proton exchange. Okay, after the proton exchange, as this is the electron withdrawing group, this proton is abstracted by this O minus, and we get this kind of intermediate. This is the important step from the benzoin condensation. Once we get this O minus, it will delocalize like this, and we will get the Cn minus as a leaving group, and finally the benzoin molecule will form. So you can see that firstly this H was not able to abstracted by the any base, but due to reversal of reactivity, it is possible that it act as a nucleophile or carbanion, and we get the benzoin condensation. So this is how the Umpolung of reactivity is studied in organic chemistry and helpful for the reversal of the reactivity of some molecules. So friends, as you know that there are you already studied the benzoin condensation. There is few limitation for the benzoin condensation and few modifications in benzoin condensation. So one very important modification for the benzoin condensation is use of thiamine salt. Instead of using Cn minus, we can use the thiamine salt, which is similarly reactive, or they can act as a nucleophile for the reversal of reactivity. Instead of everywhere we see that instead of using Cn minus, we are using thiamine. The mechanism is same to get the benzoin product. Okay, so this is how the thiamine salts are used in benzoin condensation or for the reversal of reactivity. So this is all about the reversal of reactivity or Umpolung. So this is very important topic for setnet also and for our MSc syllabus also. So this all information I am gathering from this all references. Already we discussed these references. So if you have any doubt regarding Umpolung of reactivity, feel free to ask me. Okay, thank you very much.